We're going to take a look at problem number 6 from the 4 alpha assignment, and it asks us to find the critical points of this function. G of x equals 3 times x, a linear function, plus sine inverse of x, an inverse trig function. And I want you to keep in mind that because of the inverse trig function, we have a restricted domain on which the function is actually continuous. That would be from -1 to 1, not including the endpoints. The reason we exclude the endpoints is this is a graph of inverse sine that I've drawn. This is not the actual function, but just inverse sine. You can see that at the endpoints, there's no limit, so it's not continuous at those 2 points. Now, if we want to calculate the critical points, the first thing that we're going to do is we're going to take the derivative. If we do so, we get 3 plus the derivative of inverse sine is 1 over square root 1 minus x squared. We now would like to write this as a single fraction. So what I'm going to do is I'm going to take this 3, I'm going to think of it as 3 over 1, so it's also a fraction. Then I'm going to multiply it by a creative 1. And that creative 1 is this over this. When we do that, our expression looks like so. And we're trying to find the critical points of the function, and the critical points take 2 forms. One is when the derivative is equal to 0, and the other is when the derivative is, is undefined. So if the derivative is 0, that will happen when the numerator of this function is 0. So we're going to look at when 3 times the square root of 1 minus x squared plus 1 is nothing. Okay. So I'm going to subtract 1 from both sides and then divide by 3. We get square root of 1 minus x squared is equal to -1 over 3. We square both sides. When we do that, we get 1 minus x squared is equal to 1 over 9. We're going to rearrange the equation so that x squared is alone. We get that x squared is equal to 8/9. We root both sides to determine the value of x, and at long last we get that x could be plus or minus the square root of 8, which I will call 2 roots of 2, over the square root of 9, which is 3. Notice that both of those are in our range. They're between -1 and 1, so those are going to be a pair of critical points of the function. Now let's look at what makes the function, or the derivative, undefined. Well, when the denominator is 0, since you can't divide by 0, those values would make the derivative undefined. So we're going to solve this equation. If we square both sides, we get 1 minus x squared equals 0 squared is 0. We simplify to get x squared equals 1. We root both sides, and we find that x is equal to plus or minus 1. And then we say, well, wait a minute, plus and minus 1 are outside of the range where the function is continuous. So we're going to throw those 2 values out. These are our answers.